Hello friends, I am Prof.Darshan Thakur from Terna Engineering College Dharashiv is going to explain the application of this Routh stability criteria which is to be applied over the given system. Right. Now as far as this given system is concerned, so within this given system we used to have the gain of this forward path denoted by this alphabet called it is as G. So G of S equals to k over s into s square plus 4s plus s into s plus 2, this whole term, right? So here our objective is to what? Let us quickly go through. The objective for this session is to determine the range of this k for the stability of this given unity gain feedback system. So basically it is a unity gain feedback system. So first of all, what we need to do? First of all, we need to declare the characteristics equation of this unity gain feedback system, because according to the basic definition of this closed loop control system, how it will look like? This is how your closed loop control system will look like, which consists of one forward path and one feedback path. Here the gain of this feedback path is h and the gain of this forward path is g. So transfer function equals to g upon s divided by, if we are having the negative feedback, so the opposite sign we need to consider. So it will become 1 plus g of s into h of s, right? So this is how the transfer function will look like, and when we equate the denominator of this transfer function with 0, so 1 plus g of s into h of s equals to 0. So this whole statement can be called it as a characteristics equation. So first of all, wait a minute. So what we need to do? We need to determine the characteristics equation of this unity gain feedback system. Here h of s equals to 1 and g of s is nothing but what? The given term is nothing but g of s. So we will try to determine the characteristics equation for this unity gain feedback system. So its characteristics equation will become, here I will write 1 plus this whole term, 1 plus this k over s into s square plus 4s plus 5 into s plus 2. H of s equals to 1 and it is being equated to 0. Then after that, a very simple and straightforward mathematical simplification we need to do. This whole term will get multiplied with this one. So as a result of this, it will become s into s square plus 4s plus 5 into s plus 2 plus k equals to 0, right? So this is how it will look like. So once it is being multiplied, then after that what we need to do, how this equation will become? S will get multiplied with this parenthesis. So s raised to 3 plus 4s square plus 5 times of s into s plus 2 plus k equals to 0. So one more time, we used to have the multiplication sign in between these two parentheses. So we need to multiply, or we need to do the term by term multiplication in between these two parentheses. So as a result of multiplication, here I will write, when these two parentheses are being multiplied with each other, so this s will get multiplied with this s raised to 3. So it will become s raised to 4 plus 4s raised to 3 plus 5s square, right? Then after that, this 2 is being multiplied with this parenthesis. So 2s cube plus 8s square plus 10 times of s plus k equals to 0, right? So this is how your characteristics equation will look like. Then after that, in proper manner, we need to rearrange this characteristics equation starting from highest degree of s to the lowest degree of s in descending order. So it will become, highest degree will be s raised to 4. Then how many terms we used to have belongs to s raised to 3? This 4s cube plus 2s square, 4s cube plus 2s cube. So it will become 6 times of s raised to 3 plus how many terms belongs to s square? 5 and 8. So 13 times of s square plus 10 times of s plus k equals to 0. Now this is the complete characteristics equation. Then after that, what we need to do? we need to map this characteristics equation in terms of different coefficients, right? So the coefficients are nothing but what? This will be A0, this will be A1, A2, A3 and A4, right? Now once these coefficients are being declared, here I will write, we need to declare the Routh array like this. In this Routh array, the highest degree of S is what? Which is present within this characteristics equation is S raised to 4. So here we need to put this S raised to 4. Then in the descending order, S raised to 3, S raised to 2, S raised to 1 and S raised to 0. So this is how your coefficients of this Routh array will look like, starting from highest degree to the lowest degree. The highest degree based upon the highest degree of S in its characteristics equation. Then after that, we need to declare the elements of that first row, right? So the first row elements will be what? As we know, so the first row elements will be what? Which are lying at even position, which started from this zeroth count. So A0, A2 and A4, these three elements we need to consider at first row. So A0 is nothing but what? 1. Here I will write. A2 is nothing but what? 13 times of S square. So coefficient of S square is 13. So A2 will become 13. As far as A4 is concerned, so this K itself is a A4, right? We are supposed to determine the overall range of this K, or the overall range of this unknown variable K, for the stability of this given control system, or for the stability of this unity gain control system. Moves forward path gain is equals to so and so, right? Then after that, as far as the second row is concerned, so one more time we need to collect all the elements which are lying at odd position, starting from A1, A3 and A5. So A1 equals to 6 here, as the coefficient of S raised to 3 is 6, so the A1 will become 6. A3, 10 times of S, coefficient of S is 10, so it will become 10. Obviously we don't have this A5 term, so it will become 0. Now to decide the element which is present at that third row, these two elements are being cross multiplied with each other like this. 16 into 13 minus 1 into 10, right? So 16 third is a 78 minus 10 divided by 6. So 68 upon 6, 6 6 36, 6 11 66. So it will be 11.33 here, 11.33, right? Then after that, as far as this particular element is concerned, that can be treated as a B2. So B2 equals to 6 into K, right, minus 1 into 0 divided by 6. So here it will become, only remaining element is K, right? This element will become 0. Now it's time to declare the element belongs to fourth row, whose coefficient is nothing but what? S raised to 1. So in same manner, the way in which this B1, B2 are being tabulated, in order to decide the desired values of C1 and C2, previous two rows are being taken into account. So this 11.33 into 10, 11.33 into 10 minus 6 into K divided by 11.33. So it will become 113.3 minus 6K divided by 11.33. So this element will become 113.3 minus 6K divided by 11.33. This element will become 0 because 11.33 into 0 divided by this, it has no use, so it will become 0, right? Now the last element belongs to this S raised to 0 row. This whole term will get multiplied with this K, right? Minus 11.33 into 0 divided by this whole term. So again it will look like 113.3 minus 6K into K divided by this 11.33 divided by same term 113.3 minus 6K divided by 11. So these two terms will get cancelled. Remaining term is only K, right? So when we concentrate on this Routh array, so the first column of this Routh array, which consists of how many elements? Because for stability, all elements of this first column of this Routh array should carry the positive value. Each and every element should be greater than 0 for stability. So let us quickly go through. First element is what? 1 greater than 0. 6. Second element, again it is greater than 0. Third element is 11.33, again it is greater than 0. Right? When we are coming across to the fourth element, so it will become what? Here I will write 113.3 minus 6k divided by 11.3. This whole term, it should be greater than 0. Right? In order to decide the appropriate value, see, this 11.33 will get multiplied with this 0, so it will become 0. So it will become 113.3. It should be greater than 6k. So appropriate value of this k, it should be less than 113.3 upon 6. Right? So definitely, which will carry a certain positive value, approximately 18.6 10 the 16, 16 20 the 120. So 18.3, something like this. So this will be greater than 0, right? So highest value of this k will be what? 18.3, and the lowest value of this k will be what? When we are coming across to the last element, so k, it should be greater than 0. So the desired range for this k will be what? 0 less than k less than 18.33 or 18.3 something. The value which is written within this rectangular box will be what? The desired range of k for stability of this given unity gain feedback system, which is mentioned within this forward path gain. So this is how this Routh stability criteria is used to decide the overall range of this k for sake of stability. So that can be called as the most important application of this Routh stability criteria in case of this control system engineering, right? So I just hope you had understand all these things belongs to this Routh stability criteria, how it is applicable in such a cases where we are supposed to determine the value of this unknown variable k for the stability of that system. Thank you.